So 2019, was that a good year for anything? Ducks. All right. Certainly was not a good year as far as forages go. We had a significant winter kill of alfalfa, driving the demand on on the dairy side for some high quality forage. 2018 wasn't all that great either as far as getting dry and preserved forages made. So we really had an opportunity with the prevent plant acres across northern Ohio to do some alternative or annual forage research that typically we don't have, quite frankly, the space or the acreage to do, whether it's at the research station or at the different farms at your level. We look at we'll talk about a variety of different forage options and kind of how they ranked across the state, looking both feed quality and some economics. So before we start talking about annual forages or alternative forages, I want to just make it pretty clear that it's important to, if we're going to bale these things or chop or ensile maybe those non-traditional feedstuffs, the analysis is certainly worth the money. All right. And ideally, we would have a wet chemistry forage analysis. The other options that near infrared, and that NIR analysis is great if we have kind of a monoculture, things like alfalfa, pure orchard grass, pure clover, those types of things, corn silage. But for alternative forages, we certainly recommend a wet chemistry analysis. Obviously, dry matter is important with regards to intake and nutrient density. Crude protein, all right. Ideally, we'd like to have available crude protein, but crude protein is better than nothing when we go to estimate value. NDF at neutral detergent fiber for our grass species, often the lower the better. All right, NDF is going to drive intake, and we'll show you that with the negative relationship with grasses here in a bit. NDF at 30 hours. So we've taken a subsample of that forage sample in the lab. We've put it in that cannulated cow. And this really gives us true digestibility and passage rate. Ash, we'll show you some slides, some side-by-side comparisons. Ideally, in our forage samples, ash somewhere 6 to 8%. 10's not terrible. What we found with how a lot of these annual forages are harvested, we have higher ash content, and that can become a concern. So here's that negative relationship with forage NDF and intake potential. We can see for corn silage and alfalfa, we can get our NDF levels fairly high and not have a negative impact on intake, a significantly negative impact. But once we get those grasses above 50%, we've really limited intake potential for forage, especially in a dairy situation where we're going to TMR that ration and put it in front of them. If it's a dry, round bale type deal where a choice can be made, maybe not as big of a concern. What's your feed stuff worth? We got this question a lot in the extension office. I do not like to price standing forages because we don't have a lab analysis on them. Corn silage, we can get pretty close based on a yield check and a couple different things. But we really need that nutrient analysis to estimate value. All right. And really, without getting into a whole lot of math here that Jason Hartshoe in Crawford County did for us, it's a sum of its parts. We need to know how much energy, how much protein, and how much fiber, and then we can start talking value. Here's an example from one of our forages. Nutrient value on a dry matter percent, $265 a ton. We'll see a tremendous range in values here in a bit of the samples we had in 2019. Livestock requirement, all right, you can see there for sheep from the NRC, intake varies based on stage of production, whether it's maintenance or lactation. We need a relatively high TDN, upper 50s, lower 60s, and crude protein, somewhere 10 to 15%. For that beef cow, if she's in maintenance, her requirements are actually pretty low from a nutrient standpoint, as long as we can maintain body weight. When we, of course, have a lactating beef cow, her requirements are going to be increased. Where do you think a lactating dairy animal, we're going to be higher or lower? Going to be higher, all right? Pounds of milk produced, going to be a higher demand for higher quality forage. Goats, horses, just depends. Depends on what those animals are, what we're asking those animals to do. But in general, we can get by with some lower quality forage. So Christine was supposed to be here today, and here's a graph that she pulled out of somewhere, just looking at the various species and their grazing and harvest values, just qualitatively is good, poor, fair, and such. Just the kind of the take home from this, when we look at some of our high moisture forages, whether they're brassicas, turnips, radishes, they do not make good stored forage. And we're going to see that with some of the data from our e-field studies. This is a great one-page handout. Dr. Schultz put this together last spring, looking at our forage crops, seeding rate, the kind of the ideal planting date from the agronomy guide, and we'll talk about some of those dates. Planting depth, nitrogen rates, estimated forage quality parameters. Just a nice one-page chart if you're going to plant annual forages to kind of evaluate some options there. So 2019 cover crop forage trials. What we're going to get into was done at North Central Research Station there at Fremont. We also did a similar study, a multi-species study at the Northwest Branch in Hoytville. You can see the different species listed there. When the folks at Crop Insurance come out and let us plant cover crop corn and soybeans, we thought, well, we might as well see what kind of forage that makes. In addition to, really, this is whatever seed was laying in the shed as far as species go. Because we figured if a farmer was in a pinch for feed and there was some seed available, that's what was going to be planted. 2 planting dates, one in early and one late July. Everything was no-till drilled, 10-inch rows, 50 pounds of urea at planting in the wheat stubble that had 1 pass with a disc finishing tool. All right. If we had an e-fields book, this would be in page 180, and a lot of this data, a lot of the cover crop stuff in e-fields, we didn't have the nutrient analysis back, but there is a QR code in the book where I think in about a week you should be able to scan that QR code and get a lot of this data we're talking about today. Seeding rates at the Fremont station, you can see there, quite a bit higher than some of our agronomy guide seeding rates. But this kind of started out as an observation study to see what was going to happen, but we wanted to capitalize on some data as well. Rainfall. This is at North Central Station. The red line starts July 2nd, first planting date, the green line, the end of July, out through the end of September. The earliest planted stuff had almost 8 inches of rain from the 1st of July to the end of September on it. We planted this multi-species study at the Hoytville Station in Wood County, Northwest. On the first planting date was July 15th. It's the first date we could get into the field. We put down our 50 pounds of urea, and in the first 10 days we had 4.2 inches of rain. All right, so that really was detrimental from a protein standpoint in our plantings at Northwest, because all of our nitrogen ended up downstream somewhere. Look at soybeans from Northwest. That first planting soybeans, 1.5 tons of yield, 13.5% protein, TDN of just over 50. Soybeans make a pretty fair forage. All right. Now there is some challenges if we let beans and pods develop on those soybeans from a dairy feed standpoint. You know, the soybeans high fat in the whole process of milk fat suppression. But in the vegetative stage, soybeans make fairly decent forage. What happened there on the other side of the slide? It rained. Kind of got flooded. All right. TDN is 17, almost 50% ash. That's the kind of feed a cow starves to death with a full belly with. Had 7 cows there the winter of 2018-19. Producers sent them to Reynoldsburg wanting to know why they died. They had full bellies. They died of starvation. All right, so forage quality has really been a concern the last 3 years here in Ohio.
What's the grass in the left?
Weed. Just volunteer stuff. Corn planted early July, 3.5 tons to the acre. Based on the picture, it's pretty yellow, and the protein correlates to that. You know, only 5% protein, TDN 55. That late planted July corn as a grass forage looks pretty good. All right, just shy of 2 tons to the acre, 10% protein. TDN's not super great. Probably going to have to supplement energy, but probably a viable feedstuff. Wheat planted in July, don't do it because it doesn't grow, and we don't expect it to grow as a cool season cereal grain. That picture on the right hand side looks pretty good, but those are all weeds, fescue that come into the plot. These were Austrian peas. Like I said, we just had stuff laying around at the stations. That's what we planted. You can see the difference in tonnage and protein kind of throughout these various samples match pretty well. We got kind of a trend going there. TDN still not super great as far as energy goes. Oats, when it comes to oats as an annual forage, that's probably what we have the most research on here in Ohio. We know that oats planted after the 1st of August make very good late summer, early fall forage. We can see here in these particular plots, tonnage 1.3 tons, protein just under 9%, TDN at 40. What else do we have in this picture? Seed heads. And these seed heads actually had seed in them. All right, planted the 1st of July. This was 60 days post-planting, whereas the oats planted in late July, there might be a few seed heads there, but no viable seed. All right, think about what happens to a grass in terms of forage quality once we enter the reproductive stages. Usually NDF shoots through the roof. Cereal rye, I got along a little bit better at Northwest than they did, but at 0.4 tons to the acre, the message is probably no plant it for annual forage in an emergency situation. This is just regular sorghum. It's not sorghum Sudan grass. Sorghum they had there at North Central. Tonnage over 2 tons to the acre. We can see, as we have in the other pictures, that the later planting has higher protein, probably due to what happened in terms of rainfall with our original nitrogen source. Ash content's pretty high. All right, at an ash content of 18.5%, for every 5 pounds of this forage that cow eats, or sheep, or what have you, she's going to eat a pound of dirt. All right, 20% ash is about 5 to 1 forage to dirt. So when we talk about these grass silages, did we ever have good soil conditions to harvest these things? That's the other piece. When we lay them down, we merge them or rake them together, we're also adding ash or dirt into our forages. Pearl millet, we planted this at both stations. Tonnage varied between plantings. Protein, once again, really high ash content. And part of that might have been how we harvested these plots at North Central. But when we look at the statewide data, really all of our ash levels were elevated. I wish I had a video of how these plots were harvested. A little bit of ingenuity on some county educators' parts. Involved a lawn boy lawnmower and a shop vac, but we'll leave it at that. teff grass. This is probably the grass or the forage that I got the most calls about last summer. Sorghum Sudan was maybe a little short in supply in some areas. The challenge with this, it goes to seed in about 40 days. And at a 60-day harvest, it really got ahead of us in terms of forage quality. Ideally, you mow this in about 40 days, then manage like alfalfa for the rest of the summer. 28 to 35-day cutting intervals. Like I said, just the seediness and the reproductive stage is really what limited us there in terms of energy. NDF in one of these samples was in the 70s. So this is tough to see, but these are statewide kind of summaries of the different species, single species that we tested at the research stations or that were tested on farm with samples brought into county offices and sent to the lab. You got everything from oats, some different oats variations, oats peas, oats radish, turnips. We looked at spring triticale, I said some of our cereal grains. Italian ryegrass is one that I find very interesting. It's kind of a cool season grass that we can manage almost as a warm season summer annual if you need high quality forage. Not going to get super high tonnage, but produces very high quality forage when managed appropriately. Corn, the range on our corn samples were anywhere from 1 3/4 to 14.5 tons per acre. All right, that's that late planted cover crop after the cover crop or crop insurance date corn. A couple varieties of sorghum Sudan, corn and soybean mix was in there, some more diverse cover crop mixes. We'll see that in the chart form. So those of you that can see, what's that tall blue bar in the middle? This is a graph looking at per acre value for July planted forage, all harvested in the vegetative stage. By far and away, corn returns the greatest value per acre, driven by tonnage, driven by yield. All right. We can see there our warm season kind of annual forages fall in second place. Our forage sorghums or BMR sorghum Sudan grass, soybeans. Return almost $600 per acre as a forage. Our mixes don't do so great from a forage value standpoint, especially once again if they had some of those high moisture brassicas, turnips, radish type things in them. Yield, so very similar to the last slide, and we probably should have flipped these around. Yield drives total value from a tonnage standpoint. All right. So this is a graph looking at the variety of forages. The gray bars are crude protein for the different levels of sheep and beef cow requirements. We can see that top bar across the tops are lactating sheep. Beef cow mid gestation is kind of this dark green bar. Beef cow lactating is kind of light green, second from the top. A little bit different story as far as crude protein goes. Our legumes, as expected, tend to have higher protein as a forage, whether that's soybean or clover pea mixes. Our oats did relatively well from a protein standpoint. This is TDN or energy, and maybe not the drastic variation that we have in terms of protein and value. But from an energy standpoint, as long as we can get that forage harvested in a vegetative stage, our energy is pretty good across the board. The exception there being the teff grass and the peas that were probably in the reproductive stages at harvest. Kind of switching gears to some replicated research on oats that was done at Fremont once again. If you pick up a E-Fields book here in the next couple of days, this study is also in there. So here's an annual forage oats yield study looking at nitrogen rate. Have three rates, 0, 46 pounds of N, and 92 pounds of N. Really no significant difference in terms of yield between 46 and 92. So from an economic standpoint, we can probably make the case not to over apply nitrogen to these annual forages, but they do need some, all right, to get them up and out of the ground. Similar study, or the same study and different harvest dates. Look at the difference between 45 days and 60 days of growth on those oats when comparing, this is protein, all right. See how that, certainly a significant difference as protein drops 15 days later. Energy doesn't vary as much, all right, from a TDN standpoint. TDN's still right there around 50. So in that 15-day period, we're not losing the energy value in those oats. It's the protein degradation that's happened. Oats planted at the end of July. This is looking at the same nitrogen rates, but we've also got a fungicide treatment. All right, if you studied many oat fields in 2019, or some of our small grasses, rust, crown rust, well, it was pretty prevalent. All right, from a yield standpoint of dry matter, the treated oats are on left-hand side of the slide. The untreated oats, they're to the right. Not a significant difference statistically, but 2 1/4 ton versus 1 1/2. Take your pick. All right. So depending on the cost of the fungicide that you can apply to those oats, it may or may not have paid for a fungicide treatment. All right. From a yield standpoint, from a quality, looking at the same study, nitrogen rate and fungicide. Really, crude protein doesn't change a whole lot. NDF not affected, but TDN is. All right. With our higher nitrogen rates that were treated. Nutrient value on a dry matter basis, dollars per dry ton. We can see here, because of the protein levels, it's what drives this chart, that the higher nitrogen rates did have a higher total value due to the protein content of that forage. And this might be tough to see, but this is kind of what this looks like in a plot setting. The left-hand side of the screen was not treated with the fungicide, whereas the right-hand side was. And there's kind of a faint line right about here where those oats were significantly more brown than the treated ones. And this is what we're really looking at. This crown rust leaflet on the left-hand side is about 85–86% infected with crown rust, whereas the leaves that were, or the plants that were treated with the fungicide, very low incidence. All right. What's the concern with crown rust? It's palatability. All right. Palatability as far as intake. So if we have low palatability due to the rust, high NDF, low protein, we're really putting ourselves in a situation where supplemental feed is probably going to have to be purchased. Harvest considerations for these annual forage crops. You know, primarily we're talking about grasses. In a grass situation, we think about some of our mower conditioners. Now if we're chopping this forage, that's a whole different story. We'll get to that in a minute. But if we're running this through a mower conditioner, think about what those machines are designed to do. All right, a machine that's got rollers that pushes the forage through the rollers is designed to crush stems. All right, in an alfalfa situation, that's very advantageous. When we talk about grass and having a mower conditioner that's got the flails or the impellers, we can strip that waxy cuticle off of that grass and actually increase drying rate. The flail machine, impeller machine also has greater capacity, but it's also going to have higher losses. All right, if we're mowing alfalfa, we're going to lose a lot of leaves running that through a impeller or flail machine. And if you're not on flat ground, which some of you may or may not be, there's a significant horsepower difference. With a flail machine, you can get by with, 12, 15 fewer horsepower than with a mower conditioner with rollers. All right. And that's really what these two graphs are showing. On the left-hand side, looking at the drying rate of alfalfa, the red line being rolls, the blue line being impellers. And then we kind of flip things over here on the right-hand side, where we look at the drying rate of impellers versus rolls in a grass crop situation, where we can actually speed up that drying time by stripping the wax off of those grass leaves. Storage and preservation. All right. See a lot of baleage just if you drive from here to Napoleon in the daylight, or from Napoleon to that Tiffin area. I hope there's some forward thought in making that baleage and having a home for it. All right, from a forage quality standpoint. If we're going to make baleage, that really needs to be our intention when we mow that crop. Because the worst case scenario is if we plan to make dry hay, we let that forage dry in the field, for a day, 2 days, 3 days. And then the weatherman says it's going to pop up shower. And then we bale kind of baleage, it's what I call a no man's zone. Kind of in that 30-40% dry matter. At that point, we have carmelization. It's the Maillard reaction. It's actually the same reaction that makes the outside of a hot dog brown. That's the same chemistry process. But what that's doing is when that forage caramelizes, it's binding the energy in that forage. So really, in a baleage situation, we want to test that product after it's been ensiled for forage quality. Proper dry matter, 40 to 55%. We can probably get by with 60, but not ideal. Dry hay, we want to be under 20. Certainly 20 to 30, that's kind of that spoilage zone. You need to make tight bales. All right. The caveat there is if you're in a round bale situation, you make a tight bale baleage, what happens in the winter? It freezes. So you got to have a way for those cows or those ewes to utilize that forage and still have teeth in their head when the winter's done. All right. Quicker we get that baleage wrapped, the better, and use enough plastic. All right, plastic's not cheap. We bale a lot of baleage, a lot of wet wrapped hay in our home operation. Really looking at 6 mils of plastic on that product. The most common is 1.5 mils. So that'd be 4 wraps or 4 revolutions of that wrapper. Size bales correctly. All right, if you're feeding baleage, especially out of a tube, those inline wrappers, it's kind of like managing a silage bunker. You got to make sure we keep the face of those bales fresh from a palatability standpoint. Rotate stock. Not only are there a lot of wrapped square bales out there, I know some of them are 2 years old because I've seen them for the last 2 years. All right, so how do we manage that? Not only from a forage quality standpoint, but that plastic, it's got a shelf life. It gets brittle, degrades, and such. So in a pitch hit situation, I don't think we got quite the full hour in. But if you got questions about this annual forage stuff, get an eFields book here. I assume Elizabeth's got them somewhere here in the next couple of days. Got a lot of the replicated stuff from the research stations. All the grab sample data from you guys is also in there. And that QR code with all the nutrient analysis should be there in the next week. I know we've got on the dairy things, NELs, some data on lactation. And a lot of this will be summarized here in the coming weeks on the Beef Team website.